For as long as humans have walked this earth, we've shared it with creatures of unimaginable wonder, intelligence, and mystery. We've gazed into their eyes, marveled at their intricate societies, and yearned to understand. To truly understand. What secrets do they hold? What wisdom? What warnings? For millennia, this was the ultimate barrier, a chasm of silence between our species. But what if I told you that silence is about to shatter? What if I told you that in our lifetime, thanks to a revolutionary convergence of biology and artificial intelligence, humanity is on the cusp of cracking the animal code? We are about to learn how to speak with animals. And the implications? They will fundamentally redefine everything we think we know about intelligence, empathy, and our place in the universe. Stick around, because by the end of this video, you won't just believe it's possible. You'll see how it's already beginning. And if you're as blown away as I am, smash that like button and subscribe for more mind-bending science. Stick around, because by the end of this video, you won't just believe it's possible. You'll see how it's already beginning. And if you're as blown away as I am, smash that like button and subscribe for more mind-bending science. From Aesop's fables to Dr. Dolittle, the idea of conversing with animals has been a cornerstone of human imagination. It speaks to a deep, primal yearning within us. But science, for the longest time, hit a wall. We could observe, we could interpret some behaviors, a dog's tail wag, a cat's purr. We learned about alarm calls, mating rituals, territorial warnings. But true, nuanced, bidirectional conversation? It felt like science fiction, relegated to the realm of fantasy. The sheer complexity of animal communication, not just sounds, but gestures, scents, bioelectricity, seemed insurmountable. How could we possibly bridge that gap, not just for a few simple commands, but for genuine, intelligent dialogue? The answer, as so often happens when humanity faces its greatest challenges, comes from an unexpected place, the digital frontier. So, which species are on the brink of this incredible breakthrough? Which creatures will be our first conversation partners? The targets aren't random. They're chosen for their demonstrable intelligence, complex social structures, and most importantly, their rich, multimodal communication systems that offer enough data for AI to chew on. Let's start with the giants of the deep, dolphins and whales. For decades, marine biologists have been captivated by the intricate clicks, whistles, and pulsed calls of dolphins and whales. We know they communicate complex information, identifying individuals, coordinating hunts, even naming each other. Project SETI, Cetacean Translation Initiative, is a pioneering effort armed with hydrophones, drones, and machine learning, gathering the largest dataset of sperm whale vocalizations ever. Sperm whales, in particular, use a sophisticated series of clicks called codas that seem to form distinct patterns and dialects. AI can now analyze these codas, not just for frequency, but for rhythm, tempo, and sequence, looking for the underlying grammatical rules. Imagine AI identifying a specific coda that always precedes a particular hunting strategy, or a distinct signature coda for each individual whale. The challenge here isn't just understanding. It's also about building responsive, non-invasive interfaces, perhaps underwater speakers emitting AI-generated codas, or even haptic feedback devices that mimic their unique sonar pulses. The goal isn't just to translate their language, but to engage in a back-and-forth dialogue, asking questions, and receiving answers about their deep-sea world, their history, and their understanding of the ocean. The ethical implications alone are staggering. What if they tell us about pollution, or an intelligence far older than our own? Animation of neural networks, data flowing, spectrograms transforming into text/meaning. Close-ups of scientists working with advanced computer interfaces. Asterisk narration. This is where artificial intelligence steps in, not just as a tool, but as a paradigm shift. For decades, our attempts to understand animal language were limited by human perception and processing power. We'd record a sound, analyze its frequency, maybe correlate it to a behavior. It was like trying to understand a symphony by looking at individual notes on a page, without hearing the music. AI changes everything. Think of AI as the ultimate, non-judgmental, hyper-efficient pattern recognition engine. It doesn't come with human biases or limitations in auditory range. It can sift through petabytes, that's thousands of terabytes, of data. Millions of hours of animal vocalizations, tens of thousands of video recordings of their movements, even biochemical markers, all at once. It can detect subtle patterns, nuances, and correlations that would take human researchers lifetimes, if not millennia, to uncover. It can identify the grammar of their communication, the syntax of their calls, the vocabulary of their gestures, in a way we simply couldn't before. This isn't just about translating a woof into hello. This is about decoding the intent, the context, the emotion, and even potentially the conceptual thought behind complex animal signals. It's like we've been listening to static our whole lives, and AI is finally tuning the radio to the right frequency. The first step, naturally, is listening. But the second, and arguably more profound step, is learning to respond. And that, my friends, is where the real magic and the real science begins. Next, consider the architects of the savanna, elephants. Elephants are truly incredible. They possess complex social structures, exhibit empathy, mourn their dead, and even show self-awareness. Their communication is equally complex, operating across multiple modalities. Beyond trumpets and rumbles we can hear, elephants utilize infrasound, low-frequency vibrations below the range of human hearing, to communicate over vast distances, sometimes miles apart. These infrasonic rumbles, which travel through the ground and air, carry detailed information about danger, food sources, and social cohesion. AI is essential here. Specialized sensors capture these subtle vibrations, and machine learning algorithms sift through the noise to identify specific calls and their associated contexts. For example, an AI could learn to distinguish an all-clear infrasound from a predator alert or a let's move signal purely by analyzing vibrational patterns that are invisible to us. Imagine a future where conservationists, equipped with AI-powered devices, could issue an infrasound warning to a herd of elephants about approaching poachers, or guide them away from human settlements, all in their own language. The ethical considerations are paramount. How do we use this power to protect, not exploit, these magnificent creatures? Then we turn to our closest cousins, primates, specifically chimpanzees and bonobos. The intelligence and emotional depth of chimpanzees and bonobos are undeniable. They use a rich repertoire of vocalizations, gestures, facial expressions, and body language to convey a vast array of information. For decades, researchers have taught chimps sign language or how to use lexicograms, symbols representing words. While groundbreaking, these efforts were limited by human interpretation and teaching methods. Now, AI is supercharging this research. Computer vision algorithms can analyze thousands of hours of primate social interactions, mapping specific facial microexpressions to emotional states, correlating distinct vocalizations with specific objects or intentions, and even decoding complex sequences of gestures. Imagine an AI learning the grammar of chimpanzee gestures, not just recognizing a single gesture, but understanding the sequence of gestures that conveys a desire for a specific fruit or a warning about a rival troop. The potential for a two-way interface here is immense. AI could generate visual or auditory signals that chimps understand, allowing us to learn directly from them about their social dynamics, their understanding of tools, and their intricate forest ecosystems. The questions they might answer about our shared evolutionary past could rewrite textbooks. And let's not forget the unexpected brilliance: parrots, specifically African gray parrots. While some might consider parrots mere mimics, species like the African gray parrot have demonstrated astonishing cognitive abilities, far beyond simple imitation. Alex, the famous African gray studied by Dr. Irene Pepperberg, could identify objects, colors, shapes, and even quantify small numbers, using human speech. The challenge, of course, is that Alex was an anomaly. Now, AI can generalize these abilities. Imagine an AI analyzing the context and nuance of parrot vocalizations, not just their imitations. What if a parrot isn't just mimicking hello, but using it in a way that truly signifies greeting based on the environmental cues? AI can pick up these subtle contextual patterns. Furthermore, AI could create interactive environments where parrots communicate with an AI entity, expanding their cognitive abilities beyond what a single human trainer could achieve, opening a direct window into their avian intelligence and perceptions of the world. What profound insights could these feathered philosophers offer? These aren't just fascinating case studies. They are the battlefronts of a communication revolution. We're moving beyond simple correlations to genuinely decoding intricate communication systems, driven by unprecedented data collection and the unparalleled pattern recognition of AI. So, how exactly are we pulling this off? It's a symphony of cutting-edge technologies working in concert. Advanced bioacoustic sensors. Forget simple microphones. We're talking about hydrophones that can filter out ocean noise to pick up a single whale's call, infrared cameras that detect subtle heat signatures in animal faces, seismic sensors for infrasound, and multispectral cameras capturing details beyond human vision. These aren't just recording, they're collecting data with unprecedented precision and detail. Massive data sets and cloud computing. The sheer volume of data is staggering. Terabytes, even petabytes, of sound, video, and behavioral information are being collected. This requires the immense processing power of cloud computing to store, organize, and make sense of it all. Without this infrastructure, the data would simply be overwhelming. Machine learning and deep learning, the brains of the operation. This is the core. Pattern recognition. AI algorithms, particularly deep neural networks, excel at finding hidden patterns in vast datasets. They can identify discrete units of communication, like a word or a phrase, even if they're embedded in complex noise. Natural language processing, NLP, adapted for animals. ANLP. Just as NLP helps computers understand human language, ANLP is adapting these techniques. It looks for grammar, syntax, and semantics, how sounds or gestures combine to form meaning. Reinforcement learning. This allows the AI to learn through trial and error. It can generate a sound or a gesture, observe the animal's response, and refine its output to better communicate. It's like teaching a child. The AI learns what works and what doesn't. Generative AI. The same technology that can generate realistic human speech or images can be trained to mimic animal vocalizations or even create novel, contextually appropriate signals based on the decoded patterns. This is the crucial step for speaking back. Biometrics and behavioral mapping. AI-powered computer vision can track individual animals, analyze their movements, facial expressions, and body language, correlating these with vocalizations and environmental factors. This provides the context crucial for understanding true meaning. Asterisk wearable and implantable tech, ethical consideration ahead. While controversial, advancements in miniature, non-invasive sensors or even implantable chips could potentially monitor neural activity or physiological responses in real time, providing an even deeper understanding of animal cognition and intent. This area requires extreme ethical oversight. This isn't about one single Rosetta Stone. It's about building a multi-dimensional, constantly learning bridge, brick by data brick. And it's happening faster than most people realize. As we stand on the precipice of this monumental breakthrough, we must confront the profound ethical questions that arise. Communication grants power, and with great power comes immense responsibility. Exploitation versus empathy. Will we use this ability to exploit animals further, to demand more from them, to control them? Or will it foster unprecedented empathy, driving us to protect their habitats with renewed fervor? The potential for exploitation is real, from psychological manipulation to weaponization, and we must establish strict ethical guidelines now. Redefining intelligence. What happens when an animal tells us something we never expected? What if their intelligence is fundamentally different, perhaps even superior in certain domains? Will we be forced to reevaluate our anthropocentric view of the world, acknowledging other forms of consciousness and sentience as equals? Conservation. Imagine if elephants could tell us exactly where poachers are operating, or if dolphins could warn us about approaching oil spills. This technology could be the ultimate tool for conservation, allowing us to act on direct intelligence from the animals themselves. Philosophy and spirituality. How will this change our understanding of life itself? If we can communicate with a whale about its journey through the ocean depths, or a chimpanzee about its family dynamics, it will shatter our isolation and connect us to the tapestry of life in a way we've only dreamed of. It could lead to a spiritual awakening for humanity, realizing we are not alone in our complexity. The unexpected. What if they have advanced warnings about environmental shifts? What if they possess knowledge we've lost? Or, more profoundly, what if they simply ask us, why have you done this to our planet? The answers will force us to look inwards, not just outwards. This isn't distant science fiction. Researchers globally, from the rainforests to the ocean depths, are making tangible progress today. We are laying the groundwork for a future where the babbling brook isn't just water, but a chorus of voices. Where the forest isn't just rustling leaves, but a library of wisdom. Where the ocean isn't just vastness, but a living, breathing network of communication. The journey will be long, filled with challenges, technical hurdles, and profound ethical debates. But for the first time in human history, we hold the keys to truly unlocking the animal kingdom's secrets. AI is giving us a dictionary, a grammar book, and a voice. The question is no longer if we will talk to animals, but when, and more importantly, what will we do with what they tell us? This is more than just a scientific pursuit. It's a quest for connection, for empathy, for a deeper understanding of the incredible biodiversity that surrounds us. It's a chance to mend our relationship with the natural world, to learn from creatures whose wisdom has been silently waiting for us to listen. What are your thoughts on this revolutionary future? Which animal do you want to talk to first, and what do you hope they'll say? Let me know in the comments below. If this video blew your mind, please hit that like button, share it with everyone you know, and subscribe for more deep dives into the science shaping our future. Because the silence is breaking, and the world is about to get a whole lot more interesting. Thank you for watching, and I'll see you in the next one.